Okay, in this video we're going to discuss making vectors. The first part of making vectors we actually have already gone over, and it's pretty self-explanatory, but I thought I'd get it in the notes. So if we wanted to make a vector out of a point, let's say I have point P, and I want to turn it into a position vector. If I wanted to do that, let's say point P is the position x, comma, y. So that tells me that I'm moving x spaces to the right or left, side to side, and I'm moving y spaces up or down. So the way that I put that into a position vector is the movement that I'm doing side to side, that x value, that's going to be multiplied by I. And the y value that I'm moving up and down, that's going to end up being multiplied by j. So y, j. So this gives me my position vector, and that's as easy as it is. So whatever coordinate I have, I can write it as a vector just by multiplying my x value by I and my y value by j. That gives me my direction as well as my value. So the new concept that we have to talk about with making vectors is combining individual vectors into one new vector, and this is something that we haven't done before. So let's take a look at this example, combining individual vectors into one vector. So here off to the side, I have written down some vectors. So they have the pointy brackets that tell me that these are vectors. So I have the vector 1, 2 to start with. I'll call this vector A. And if it's vector A, it's got to have a little arrow on top of the A to tell me that this has direction. So it's 1, 2. So I can graph that over here by going over 1 in the x direction and up 1, 2 in the y direction. So I can start with a point, and then I can turn that into a vector by turning it into a line with direction. There's my vector. I also have vector B. It's down here. This is the one at the bottom, 3, 5. So vector B is going to be going over 1, 2, 3 and up 5. 1, 2, 3, 4, 5. So it'll start with a point. Then I'll turn that into a vector by turning it into a line. There we go. The line always goes to the origin, which is the point 0, 0, and it tells me how far over and how far up I went away from the origin. So I have these two vectors, A and B. Let's say I wanted to find out how far it was from A to B. The way we could write that is A, B with a line over it. That means I'm starting at vector A and I'm going to vector B, and I want to find out how far that is. And vector AB is measured from the tip of vector A to the tip of vector B. I want to find out what that new vector is. The way that I have to calculate that is kind of unique. I have to start at the tip of vector A and figure out how far over I have to go to get to line up with vector B's endpoint. So in order to get from this point to where I can line up with vector B, I have to move over 1, 2 spaces. So I've moved 2 spaces to the right. I've moved 2 spaces on the x-axis, which means I moved 2I. So 2 spaces in the x direction. Then I have to figure out how far I have to go up so that I can reach my new point. So I have to count, I have to move up 1 space, 2 space, and 3 spaces in order to get from this height to this height. So that's 3 spaces in the y direction, that's 3j. So if I take vector A and I move to vector B, this is the resulting vector. I had to go over 2I and 3j, and that would bring me this direction, connecting those two vectors. Now, we don't have to do this with graphing. In fact, graphing is a little over the top. We can actually just do this mathematically, and it's actually very straightforward. In order to figure out the distance between these two vector endpoints, all I have to do, like I did in my math, is figure out how far it is between my x values and how far it is between my y values. And the easier way to do that, rather than regraphing, is just to use subtraction. So vector A is 1i plus 2j. I'm moving one space in the x direction, 2 in the y direction, and that's vector A. Vector B is 3i and 5j. That's vector B. I've moved 3 spaces in the x direction and 5 spaces in the y direction. If I want to find how far it is between them, all I have to do is take the values from vector B and subtract the values from vector A. And it'll give me the difference that I'm looking for. Let me get my arrows on here so I don't forget. These are vectors, not just points or lines. So if I take my values from B and subtract my values from A, it will actually give me the resulting vector just through subtraction. So how far is it from A to B? Well, that's the value I ended up at minus the value I started with. So in my x direction, I started at value 1 and I went to value 3. So if I do 3 minus 1, it tells me that the distance that I traveled is 2. And I found that number. So all I did was 3 minus 1. And then to figure out how far I went up, I started at point 2. I needed to go to point 5. How far is it between those two things? Well, that's just 5 minus 2. That gives me the 3 that I had in my answer. So all I have to do to find the distance between two vectors is just subtract the vectors. I have to take the place where I stopped and subtract the place where I started. So if we wanted to look at that generically, here's what that would look like. Given vector A is some vector mi plus nj, so whatever those numbers happen to be. And vector B is this whole other vector with values ri and sj. In order to find the length from A to B, all I have to do is take vector B and subtract vector A. Oh, that's supposed to be an A. I'm sorry, getting a little dyslexic over here. So vector B minus vector A, and the resulting vector will be vector B ri plus sj minus vector A, which is mi plus nj. Remember to use parentheses. It is vital when you're subtracting, and a lot of what we do with vectors is subtraction. We have to make sure to distribute this negative to everything inside here. That's really all there is to this process. So let's go ahead and actually jump into some examples, and we're going to be able to get some good practice with this method. All we have to do is take the place where we want to end up and subtract the place where we started. So let's take a look at some examples. So we have the position vectors A, B, and C. Your problem might tell you the phrasing in this form. They'll say position vectors A, B, and C are 2i minus j, 3i plus 2j, and negative 3i plus 4j, respectively. And what that means is that A is 2i minus j. B is 3i plus 2j, and C is going to be negative 3i plus 4j. So the first one they mention is going to be the first letter of the alphabet. The second one they mention is going to be the second letter of the alphabet, and so on and so forth. So here are our position vectors, A, B, and C, and we're going to be asked to find all sorts of things about them. The vector AB, and these two lines on either side, which if you recall means the magnitude of that vector. So we're going to have to figure out how long that vector is. And then we're going to have to do that with these vectors as well. So let's just go ahead and jump into the first problem. We need to find the magnitude of vector AB. So the magnitude of vector AB. In order to figure out the magnitude of this, I'm going to have to start by finding AB. I have to figure out what that is. So AB, the distance between A and B. In order to discover the distance between A and B, I have to take vector B and subtract vector A. Remember, we always take where we ended up and subtract where we started. So vector B minus vector A. So vector B was 3i plus 2j, and I have to subtract vector A, which is 2i minus j. So this will guide me toward my answer here. So I'll start by distributing my negative sign inside. So I have 3i plus 2j minus 2i plus j. And if I go ahead and combine my like terms, like I know how to do now, I have 3i minus 2i. That just gives me I for an answer. And I have plus 2j and plus j, which gives me plus 3j. So this is my vector AB. Now, I have to find the magnitude of this vector. For magnitude, remember, I have to take the square root. This is the distance formula. So the magnitude of I plus 3j is going to be the square root of the coefficient in front of I, which in this case is just the number 1 squared. And I have to add the coefficient in front of j, which is the number 3 squared. Your answer will always be positive numbers being added together. You should never get a negative sign or subtraction inside here. That is always incorrect. It's always going to be positive and addition. So this is going to be the square root of 1 plus 9, which gives me the square root of 10. And that's my final answer. I can't simplify that at all. So we found the magnitude of vector AB. Let's work on the next one. Let's work on the magnitude of vector BC. So if we want to find the magnitude of vector BC, the first thing we need to do is find what BC is. So to find BC, we have to do vector C minus vector B. Remember, we always start with where we end up and subtract where we began to find the distance between them. So vector C, which is negative 3i plus 4j, and we have to subtract vector B. Vector B, in parentheses, is 3i plus 2j. So we'll start solving this by distributing our negative sign just like before. This has to go inside to every single term. So I'll end up with negative 3i plus 4j minus 3i minus 2j. I have to distribute that to everything inside. And when I go to simplify this, I'll have negative 3i minus another 3i. I'll have negative 6i. And I'll have plus 4j minus 2j, which is just plus 2j. So that's my resulting vector. That is vector BC. Now I need to find the magnitude of that vector. So magnitude of negative 6i plus 2j. And in order to find my magnitude, I'll use that distance formula. It's the square root of the coefficient in front of I, which is negative 6. That whole number is going to be squared. It is very, very important to use parentheses there, so I square negative 6, not just the number 6, and then make it negative. So I'm squaring the whole negative 6. And then I'll add the coefficient in front of j squared. So this is going to be the square root of negative 6 squared, which is 36, plus 2 squared, which is 4. So this is the square root of 40. And that's my final answer for that question. Let's take a look at the next one here. We are trying to find the magnitude of vector AC. So in order to find the magnitude of vector AC, first I'm going to find what vector AC is. And in order to do that, I have to do vector C minus vector A. We always take where we left off and subtract where we started. So vector C minus vector A. So vector C is negative 3i plus 4j, and I have to subtract vector A. In parentheses, that was 2i minus j. So let's go ahead and distribute our negative sign here, just like we did before. So we have negative 3i plus 4j minus 2i plus j. I'm going to change those signs in there. Now let's go ahead and simplify this here. Negative 3i minus another 2i is negative 5i. And we have plus 4j plus another j, that's plus 5j. All right, so we have our vector AC. Now we have to find its magnitude. So let's find the magnitude of negative 5i plus 5j. This magnitude is going to use that distance formula. We'll take the coefficient in front of I, negative 5, and we'll square that in parentheses. And then we'll take our positive 5 and square that. We're always going to square them and add them together. Always positive, always being added together. So this is going to be the square root of 25 plus 25, which is the square root of 50, which again doesn't simplify, so that's where I can leave it. We've got one more problem to do. This is asking us to find the vector, the magnitude of vector CA. So vector CA, in order to find that, first I have to find what CA is. And in order to find vector CA, I have to take vector C, just kidding. I always start with where I ended up. I have to take vector A and subtract where I started, which is vector C. So don't make the same mistake I almost did. Don't just start with the first letter. You always start with what you ended up with, subtract where you began. So vector A minus vector C. So vector A is 2i minus j, and we have to subtract from that vector C, which is negative 3i plus 4j. Please use parentheses every time you subtract. It's very, very important to distribute our negative signs. So we can distribute that negative. We have 2i minus j plus 3i, big difference there, and minus 4j. When we combine these things, we'll have 2i plus 3i, that's 5i. And here, negative j minus 4j is minus 5j. So that's our vector, CA. It's very similar to vector AC, except the signs on I and the signs on J are the opposite signs. That just means we're moving the same distance, but we're going the opposite directions on those. Now, when we find the magnitude of 5i minus 5j, it's going to be the distance formula, where we take our first coefficient, 5, we square it, we add our second distance coefficient, negative 5, squared. Remember, these will always be positive, and they'll always be added together. So our square root will be 25 plus 25, which will give us the square root of 50. Now this makes sense. The distance between AC, that magnitude of the vector AC, and the magnitude of the vector CA, because all that means, if we go back to our graph example, it just means that I had two vectors here, and the first time I measured going this direction, and the second time I measured going this direction. The length of that green line won't change. It's just which way you have to go. Do you have to go to the right first and then up, or do you have to go to the left first and then down? That's the only difference there. So the magnitude of those should be the same. So that is correct that we found that answer. All right, that's it for this lecture. You do have homework posted on Canvas. It will be due tomorrow. That's Friday. So please go ahead and get started on that and let me know if you have any questions.